Good morning, students. Students, this lesson is of class 8th for the subject of physics. Topic: types of non-contact forces and Newton's first law of motion. Given in chapter number 3, laws of motion. This lesson is submitted to you on 12th July 2021, and this topic is given on page number 58 of your physics textbook titled Concise Physics by Selena Publications. Now students, you are requested to open page number 58. Starting with non-contact forces, children, as its name suggests, the forces experienced by bodies even without being physically touched are called non-contact forces or forces at a distance. So, the forces which a body experiences without being physically contacted or touched are called non-contact forces. Now, children, if you pick a pen in your hand, so suppose you pick a pen in your hand in air and then you remove your support, you remove your hand, then what will you observe? What happens? Suppose you are having pen in your hand and you have raised the pen above the ground. So what will happen? If you remove your hands, what happens? This pen falls down. Even every object falls down when you remove the support from it. So why everything is falling down? If they all are falling down, that means there is some force pulling them downwards, but still there is no contact of any other object with this pen which is falling down. So children, now let us study in detail which force is acting on all the objects such that all the objects are falling down. Children, in universe, each particle attracts the other particle due to its mass. Sun attracts Earth, even Earth attracts Sun. Earth attracts us, even we attract Earth. Everything which is having mass will attract each other. This force of attraction between them is called gravitational force. Which force? Gravitational force. Now students, the Earth, because of its mass, attracts all the other masses around it, and it is the force due to gravity that makes a body fall when released from a height. For example, right now, if you release your pen from a certain height, it will fall down. Why? It happens because the Earth's gravitational force is attracting the pen towards itself. So this force is known as gravitational force. Second type of non-contact force is electrostatic force. Now children, remember that two like charges repel each other while two unlike charges attract each other. What do we mean by like charges? Same kind of charges. For example, positive charge, positive and positive are like charges. Negative and negative charges are like charges. So if you bring one positive charge towards the other positive charge, what happens? They both will start repelling each other. You can't bring them close. Similarly, negative charge they will also start repelling each other. But unlike charge, that means one positive, other negative. Now they are unlike charges. If you bring two unlike charges close to each other, instead of repelling, they'll attract each other. So children, this force of attraction and repulsion occurs when the two charges are not in contact, rather they are at a distance. So the force between the charges is called electrostatic force. For example, when a comb is rubbed on dry hairs, when a comb is rubbed on dry hairs, it gets charged, and then this charged comb, when brought near the small bits of paper, makes the paper attract towards the comb without even actual contact. Now, children, the third type of force is magnetic force. That is also non-contact force. Children, as we were having two like charges, similarly, in case of a magnet, you are having two poles. A magnet has two poles. If we have a magnet, it has two poles, namely north and south pole. Each magnet is having a north pole and a south pole. Now, children, suppose we bring one more magnet, and if I bring the north pole of the other magnet towards the north pole of the first magnet, this north and north are like poles, and like poles always repel each other. They will move away from each other. You can't bring them closer enough. After a certain point, they will start repelling each other. But children, if I bring south pole of the other magnet close enough, suppose I bring south pole of the magnet near the north pole of the first magnet. Now they are unlike poles, opposite poles. What kind of poles they are? They are unlike poles. Unlike poles mean opposite poles, and opposite poles will always attract each other. They will come closer to each other. Though they were not in contact, when you bring in closer, this force of attraction and repulsion occurs on their own. You are not contacting the two magnets. So children, two like magnetic poles repel each other, while two unlike magnetic poles attract each other, and the force between the magnetic poles is called magnetic force. Now children, what happens when you bring magnet close to iron nails? What happens when you bring magnet close to iron nails? You must have seen iron nails get attracted to magnet without actual contact initially made between both of them. So children, in this non-contact forces, we are having three non-contact forces. That is, firstly, we did gravitational force, then we did electrostatic force, and the third was magnetic force. Students, electrostatic and magnetic forces can be attractive or repulsive. It can happen that they are repelling each other, unlike charges attract and like charges repel. Similarly, like poles repel, unlike poles attract. So children, repulsive and attractive forces can be both electrostatic and magnetic. But gravitational force, that is never repulsive. It is always attractive in nature. So gravitation force is attractive in nature. Now children, we will start with Newton's first law of motion, which is given in exercise 3B. We are done with 3A exercise. Now let us move to 3B exercise. So children, according to Newton's law of motion, which is also known as law of inertia. Law of inertia. So according to Newton's first law of motion, if a body is in a state of rest, that means if the body is at rest, it will continue to remain in same state of rest. And if it is in state of motion, it will remain moving in the same direction with same speed. So if the body is at rest, it will continue to remain at rest. And if the body is in motion, it will continue to remain in motion with same speed and in same direction unless and until an external force is applied on it. Unless and until an external force is applied on it. Now students, kindly pause this interactive session and look around yourself. What can you see? Can you see your books lying on a table? See? And then you can see bed and other furniture placed on the floor. If I ask you to move your book or move a chair or move a bicycle, how will you do? Try to move these objects and then resume further to know the reason. You will require to apply force if you want to move all these objects. So you will require the application of force to move all these objects: bed, bicycle, chair, book. You have to apply force to move them. Students, even if you need to stop a bicycle, you need to apply a retarding force. That is, a force is applied in opposite direction in relative to the direction of motion. So if the motion is in a forward direction, if you want to stop a bicycle, you have to apply force in opposite direction, which can be achieved by applying brakes. And this retarding force is applied by applying brakes to the vehicle. So students, now let us learn some important definition which is related to Newton's first law of motion. The first definition is inertia. Inertia, I-N-E-R-T-I-A, inertia. So children, the property of an object by virtue of which it tends to retain its state of rest or of motion. The property of an object by virtue of which it tends to retain means continue to remain in same state of rest or motion is known as inertia, and it is the inherent property of each object. And there are two categories of inertia. One is inertia of rest, and due to this, object will remain in state of rest. And the second category is inertia of motion, due to which object will continue to remain in state of motion. So that is all about inertia. And then coming to the term force. Force is that external cause. It is the external cause. You have to apply it. So it is external to the body. Force is that external cause which tends to change the state of rest or the state of motion. And the force will be studied in detail in exercise 2C. Now children, inertia, what was inertia doing? The property of inertia, the property of an object by virtue of which it tends to remain in same state, and force is that cause which tends to change the state of rest. So inertia helps the object to remain in same state, while force will help the object to change its state of rest or state of motion. They are opposite to each other. Now children, pause this session and in the meantime write the definition of mass. We have done mass in class 7th, chapter number 2. What was mass? Kindly pause the session and write down the definition. And then you can resume further to cross-check your answer. Hurry up, write down the definition in your notebook. So written? Very good. So what is mass? The matter contained in a body is known as its mass. So what is mass? The matter contained in the body is known as mass. Children, the property of inertia is because of the mass of the body. Kindly remember this. This is a very important statement. The property of inertia is because of mass of the body. Greater is the mass of the body, greater will be its inertia. Children, a lighter body has less inertia than a heavier body. Or you can say more is the mass of a body. It is more difficult to move the body. It's very tough to move a heavy body because its inertia is more. And inertia will allow the body to remain in same state. So if a heavy body is at rest, it is having high value of inertia, which do not allow the body to change its state of rest. So children, now you can see figure 1 shown on page number 4, figure number 1. And there are 2 shopping carts. One is empty cart and the other is filled with groceries. So children, now you tell me which will require more force and why? If you want to move these carts, which cart will require more force and why? Write down the answer in the notebook and also write down the reason why should be written, why you are stating an answer. Written? So yes, answer number 1 will be unloaded. Unloaded means empty. Unloaded shopping cart requires less force to move because its mass is less. Since its mass is less, that means the inertia. Listen, students. The mass of an unloaded shopping cart was less than the mass of loaded trolley, and hence the inertia of empty cart is also less. So that means if its inertia is less, that means it can be moved very easily. Its state of rest can be changed easily since it was at rest, while the loaded cart is having more mass and its inertia will be also more. So if its inertia is more, then you require more force to change its state of motion or rest. Now students, try to push a table placed at your house, and then try to push your bed. What do you observe? You must have experienced that pushing the bed was more tough relative to pushing a table. This happened because the mass of the bed was more, and thus its inertia was also more. So children, with this, I come to an end to this interactive session, and you all are required to go through the PDF thoroughly. Thank you, students, and have a nice day.